Kia ora whānau. Welcome to our first video in my series on testing and meters. Today we're going to go through the basic functions of our multimeter. Let's get straight into it. So you can see here my multimeter. I've had this one for about 15 years, and if you look closely, it's got a few battle scars on it, but it still does the job. If you look after your meters, they will look after you, and they can last quite some time. Just looking at the meter itself, you can see the main feature here is the rotary switch in the middle, which allows me to switch between the different functions. A multimeter is, as it says in the name, capable of doing multiple different things, which is why we use it. This is the cornerstone of our electrical toolbox, if you like. This is what keeps me safe, ultimately, because I'm able to test when I'm safe or when I'm not safe, and it allows me to figure out what's going on in a circuit, whether it's live, whether it's dead, all of those kind of things. Just a point to note that my meter may look a little bit different to yours. Well, in fact, it will look a little bit different to yours, and some of the functions may look a little bit different, but I'll explain them in a very generic way, so you should be able to compare between your meter and this one and figure out what does what. So obviously at the top there we have the off position. That's where I leave it when I'm not using it, so I don't waste the batteries. And if I click it one place to the right, we can see these two symbols here. That one and that one. Let's have a look at what those mean. So we are looking at these two here, the one that says continuity buzzer and the one that says diode. So the continuity function there allows me to test whether a wire is continuous from the end to end. It's a form of resistance testing. And when I have a circuit, it will beep. Very helpful if I can't look at my meter while I'm testing. It just gives me a little audible beep to tell me what's going on. The second function there is a diode. That is a symbol, the electronic symbol for a diode, and that denotes that that function is diode testing. You will see if you look at the meter, as we just saw, that both of those functions, although they're quite different, are on the same position. You may have on your meter some separate functions for those, or you may have a button that allows you to choose between them. You may find on different settings where I have separate ones, yours is combined. Either way, there is some function for switching. This one here does not have such a switch, which tells me that it does it automatically. So it will detect whether there's continuity there or whether it is a diode, and it will display the correct output for me. So if we move on to the next one, we will see here it says VDC, and I've got three different functions grouped into that section there. VDC stands for voltage DC, and I've got three ranges, 1,200 and 2,000 M, which stands for 2,000 millivolts, which is also the same thing as 2 volts. 2,000 milli is the same as 2. Just have a look at our symbols again, and we can see at the top here we have these symbols here. V equals volts AC or DC. My meter has separate functions for AC and DC volts. You can see there on this side I've got DC volts, and on this side I have AC volts. Some meters will have that, some meters may not. The symbols here, as you see them, DC with the line and a dotted line underneath, and AC with a line and a wavy line underneath. The dotted line denotes DC, wavy line denotes AC. That's how I will know which function is which. It may also say AC or DC, and it will have a V next to it for volts. So that's how I know that that is the AC or DC voltage function. You may find you have one function with all of those things combined. Those symbols will be together on a single place on the switch. That is generally an auto-ranging function. As I mentioned, the meter will figure it out itself. If you've got a clever meter, it will figure out whether it's AC or DC and display the correct result accordingly. Speaking of ranging, that is what my figures there, 1,200 and 2,000 M for. So if I'm measuring up to 1,000 volts, I use that one. If I'm measuring 200 volts or less, I use that one. And 2 volts or less, I use that one. And you may be able to see there as I select those functions, the decimal point changes. So all that's doing is giving me a more accurate reading, changing the decimal point depending on the level of voltage that I am measuring. If I measure a higher voltage than the function, it won't damage my meter. It just won't display the result correctly, or may not display the result at all. Again, your meter may have separate functions like this, like mine does, or your meter may do auto ranging and figure it out for you. Or your meter may have a button that says range on it, and you can select that and cycle through the different ranges. Different meters will have different ranges. As I said, it's unlikely that you'll damage your meter by choosing the wrong one, so feel free to experiment with that to find the one that you need. If we just flick around to the left-hand side here, you'll see I've got VAC. So volts AC. So I have a separate function on my meter for voltage AC and DC. And again, I have three ranges: 2000 millivolts, 200 volts, and 750 volts. So once again, exactly the same with the DC. I select the correct range and for the thing that I'm testing. If the voltage is unknown, I would go to the highest one first. I always want to select a range that's higher than the thing that I'm testing. So if I'm testing standard 230 volts here in New Zealand, I would select that 750 volt function. We won't go into the differences between DC and AC, but obviously I need to select the right one. AC volts are what comes out of the wall, out of my socket. DC volts out of a DC power supply or a battery. Moving back around to the right-hand side, we get to the bottom and we see this funny symbol here. Once again, I have two ranges, 200 and 200K. K in this means kilo. So 200 kilo, 200,000. So I have a 200 range and a 200,000 range. And that symbol there means resistance. So that's our Greek letter omega, which we commonly use to denote ohms. And ohms are our unit of measure for resistance. So that tells me that this is the resistance function. I can use that to measure the resistance of a device, maybe a resistor or a piece of wire or whatever it is that I want to measure. Again, I'm not going to go into the details. We'll have more videos on the actual testing of each of these things. I select the correct range. So 200K goes up to 200,000 ohms. That's pretty high. 200 goes up to 200 ohms. Won't damage my meter if I choose the wrong one. It just won't display the correct result. Your meter, once again, may have auto ranging or a button to cycle through the ranges. Going over to the left, we see here MFD. Now, actually, my meter is a bit odd in this respect. Your meter is very unlikely to say MFD. This means microfarad. The symbol that you are likely to see is this one here. The two parallel lines with lines sticking out the end, which is the electronic symbol for a capacitor. And hence, we're measuring capacitance. Now, capacitance is measured in farads and usually microfarads because our capacitances are very small. Hence, my meter says MFD, which means microfarad, but it's doing the same thing as if you had that capacitor symbol on your meter. This one goes up to 200 microfarads. I can use this for testing a capacitor. It will tell me what the capacitance is. Capacitors are generally labeled with what the capacitance is supposed to be. So this one is a really helpful, quick test to see whether that capacitor is functional. If it doesn't give me a reading, it's probably not working. If it gives me a different reading to what's printed on my capacitor, then something has obviously gone wrong. And this is helpful when we're diagnosing faults in motors and things like that, where we have capacitors for starting. We will look at capacitance testing perhaps in another video. The final function on here, AAC, amps AC. So amps AC, and it goes up to, you can see there, 200. It also has this weird little symbol underneath. You can see that there. That's a bit of a strange one. What that is a picture of the top of my meter, this little clamp device here. When I'm measuring current, there's two ways to do that. One is to unwire the circuit, and I take my 2 meter probes and place my meter into the circuit so the current flows through my meter and I measure it that way. This meter does not do that. This meter has a clamp on the top. And what I do is place a wire that has current flowing through it inside the clamp, and the meter will tell me how much current is flowing. It does that by picking up the magnetic field around the conductor. You may find most cases your multimeter will not have a clamp on it. You may have a separate meter with a clamp on it, and it may also incorporate some of the other multimeter functions. But most people will have a multimeter and a clamp meter. So the clamp meter is a great way of measuring current in a circuit without breaking that circuit. Point to note, if you do have a meter that does not have a clamp and has a current function, you need to measure it through the meter leads. You will find that there are additional probes or additional sockets in here, and I would change where my lead is plugged in for measuring current. It's really important that you get that right, because in this case, you will damage the meter if you have the probes in the wrong place. Particularly if I have them on my normal setting and I try to measure current, it may blow my meter up. You can see there I only have 2 holes in mine, which makes it nice and easy. All the sockets will be labeled, so if your meter does have those current functions, have a look at the sockets and it should tell you where the leads go depending on what function you are using. My meter also has this button here, which is a max button. That's if I want to measure a value that is changing rapidly and I can't see it fast enough to be able to do that. I hit the max button. You can see max comes up there on the screen, and it's going to read the highest value in that circuit and then display that value continuously until I turn the max value off. Many meters will have a similar function to that. It may also be labeled as hold or max hold or peak hold or something like that. Right, so those are the basic functions of our multimeter. As I said, we're not going to go into detail around the tests themselves. They will be in separate videos. I'm going to be doing a series on testing. We're going to cover things like resistance and continuity, voltage, current, RCD testing, earth loop impedance testing, all of that sort of stuff, all the necessary things that you need to do to be able to perform testing as an electrician or as an electrical apprentice. So if you're interested in that stuff and you want to see more, have a look on this channel and you will see those other videos. Thank you so much for tuning in, and hope to see you at the next one. Thanks.